Hi, everybody. My name is Stephen Aber, and I am the Communications and Marketing Manager at the Environmental Research and Education Foundation. Welcome to our Scholar Spotlight session. Today we have Sonia Moavenzadeh, and she is going to present her work on PFAS. So we can go ahead and get started. Sonia, if you want to put the slides up, we will commence. There is not CE credit or continuing education credit for those of you today who are used to that. There will be in future science sessions, but not today. The only thing that we have for housekeeping is just questions. And if you want to ask us questions, feel free to drop those in the chat at any time as we go through. Tony's going to present her work first, and then we will just sort of get to know her a little better at the end. I'm Stephen. Again, like I said, I've been with EREF since 2023. This is my first science session to moderate, so I'm excited to learn more about Sonia here. And we want to talk a little bit about our scholarship program to start, if you're not familiar with it. Are we presenting slides, Sonia?
Uh, yeah. So should I get it
Okay.
started?
I haven't been on the, yeah, you can go ahead and get the scholarship slide up. So
Mhm.
our scholarship program supports students pursuing master's and doctoral waste management research. We provide a monthly stipend from the time that it is awarded until the student graduates, which if you're not familiar with the program, that's something very unique that we do. It's not a one-time gift or a limited gift. It is a support through the entire tenure of that scholar's research. Students work on projects related to a number of materials management issues. You can see all about our current scholars on our website, erefdn.org. And we have just concluded several weeks ago the scholarship process. We will again take applications starting in December. Okay, so they cannot see the slides, Sonia. So if you want to share
Oh,
screen, I cannot see
okay.
them. We'll take 1 second to get those going.
So wait a little. I don't know what happened. Hold
There we
on.
go.
Oh, okay.
All right, your screen's up now, so just pull up the slides and we'll be good to go. Perfect. All right. So yes, as I was saying, monthly stipend until graduation. We support a number of research projects. The specific link is erefdn.org/scholars. There you can see all of our scholars, current and past. We currently have 33 scholars on the website, and you can review all of the things that they're doing, number of things across the industry. And so at this point, I will introduce Sonia. She is a PhD candidate in environmental engineering at the University of Maine. And if you were in the South, like we are here at EREF, she just took off her jacket in Maine. So they're having much nicer weather than we are here. Her focus is on behavior of PFAS at soil water interfaces, and her expertise includes PFAS absorption mechanisms, biosolids management, landfill design, and advanced water and wastewater treatment technologies, including the use of activated carbon and data driven modeling. She was awarded the EREF Scholarship in 2023 for her research on the release of PFAS-laden leachate from landfills. Beyond her technical work, she has leadership roles in several graduate student organizations, which reflects her commitment to scientific advancement and academic community building. So that's the formal introduction. Sonia is now going to take it from here and talk about her research.
Yeah, thank you for the great introduction. And sorry if my laptop freezed, I guess, for a second. So, hi everyone. Thank you so much for joining today's Scholar Spotlight session. In this session, I'll be sharing a bit about my background and highlighting the research I've been doing on PFAS, those persistent tricky chemical compounds. Honestly, it means a lot to be here today, especially because this scholarship has been such a turning point in my journey. So let's get started. I was born and raised in Iran, a beautiful country in the Middle East with four seasons and a rich culture that goes back thousands of years. Here, there's a picture of me when I was 1 year old. yeah, the youngest in the family. As a child, I loved being outdoors and had a natural interest in building things. I remember on trips or vacations, I would spend hours near small streams building mini dams with rocks to redirect water, sometimes just for fun or sometimes with a mission in my mind. And my dad used to joke that I was running a construction site by myself. That love for building things and solving problems stayed with me, and I knew early on that civil engineering was the right path for me. To give you a little background about universities in Iran, I should say actually entering a top university is not that easy and requires passing a highly competitive national exam. I was able to pass the exam for my bachelor's and master's degree, and both with full scholarships. My interest in environmental engineering actually began in undergrad through coursework and final projects on municipal water systems and water treatment, and it even grew stronger during my master's, where I worked on wastewater treatment using MBBR systems. Um, and in those pictures, you can see my graduation for both my bachelor and my master's. For my PhD, I always wanted to study abroad, especially in the US, because I think it offers many opportunities. It has advanced research facilities, a strong infrastructure, and I believe it would be an especially empowering environment for women in engineering. So I came across my advisor's lab. Uh, uh, and I sent out an email. I found an open position in his lab at University of Maine, and I reached out to him, and we set up a meeting, and I prepared a presentation to introduce myself, introduce my work, and my research interests. Later, after I became his student, he told me I was the only one who gave a presentation, which made me stand out and left a strong impression on him. Yeah, this email here is when I found out I got the position, and it still makes me smile. And all of this was during COVID, so everything was delayed, embassies were closed, borders were tight. But eventually, I made it to the US and started my program in fall 2021, and I've been grateful ever since. This slide brings back a lot of memories. After all the waiting, rescheduling, and worrying during the pandemic in 2021, I finally made the big move from Iran all the way to Maine. It was my first time traveling such a long distance, and let me tell you, nothing says a new chapter quite like having everything in two suitcases and a backpack, and also have a heart full of excitement. But I have to be honest, that moment at the airport with my family saying goodbye, I was deeply emotional, especially knowing I wouldn't be able to see them in person for years. But it also reminded me how lucky I am to have their full support, even from thousands of miles away. Coming to Maine was a big change for me. New culture, beautiful nature, and a different climate. And oh my goodness, about the snow. Especially in my first winter here, we have a saying here that we say if we survive the first winter, we probably survive the rest of them. But UMaine quickly became home. I met wonderful people, friends, lab mates, professors. I started working in the lab and got involved in research, went on field trips to collect samples, and soon after, I started presenting my work at conferences. One of my first poster presentation was just a few months after I arrived at the Maine Sustainability and Water Conference, and you can see that moment captured in the photo at the bottom with my advisor, Dr. Apul. One other things that here I want to mention is that, of course, living far from home came with its own challenges. For example, one of the changes that I had to make in my life was having video calls. And it was like the only way for me to be there for my family, to celebrate family birthdays, share important events, or just having virtual dinners together. It was basically my little window to home. But anyway, every step of this journey has helped me grow, not just as a researcher, but as a person navigating life far from home. And I also like to say this journey wasn't just about crossing borders, it was about getting closer to the version of myself that I always wanted to become. Um, so in this journey, one of the most meaningful turning point in my PhD journey came through my connection with EREF, the Environmental Research and Education Foundation. In September 2022, I attended the ICLRS conference in Asheville, North Carolina, which was held in partnership with EREF. That was my very first in-person oral presentation in US, and I still remember how excited and nervous I was. And I presented my work on PFAS interaction with landfill geomembranes and how liner damage can affect PFAS migration. At that time, it was a fascinating topic and a great experience for me. After the conference, I felt more confident in my work and more connected to the environmental research community. So in the beginning of 2023, I decided to apply for the EREF Scholarship with my supervisor advice. And by almost the end of 23, I was able to receive it. I won the scholarship, and that was a very special moment for me. That acceptance letter and feature on EREF website meant more than just recognition. Actually, it was an encouragement. It reminded me that my research matters. And I think EREF didn't just give me funding, they gave me momentum. They helped me feel seen, which I think is really important to have the motivation to move forward. And EREF definitely helped me to move forward with confidence and to take on new challenges without the stress of wondering how I would make things work. And definitely, it also gave me the chance to attend more conferences, share my work, and shake more hands. And for all of that, which helped me grow in my field, I am truly grateful. Here I will briefly explain about my research, projects, and related publications. But before diving into my research, I want to briefly introduce what I work on. PFAS or forever chemicals. PFAS are synthetic compounds used in products like non-stick pans, waterproof clothes, shampoos, and food packaging. And they are called forever chemicals because they don't easily break down in the environment and they owe it to their strong carbon fluorine bonds. So unfortunately, as a result, PFAS have contaminated drinking water, groundwater, and even our soil. They have been also found in most people's blood and are linked to health issues like liver damage, immune suppression, and certain cancers. So while these chemicals are useful in industry, and consumer products, they come with serious environmental and health concerns. And that's where my research comes in, trying to understand their behavior in environment and finding ways to limit their spread. Here I want to talk about PFAS major carriers. Actually, PFAS travel through specific pathways before ending up in soil and water. Some of the major carriers of PFAS in the environment include wastewater treatment effluent, firefighting foams, landfill leachate, biosolids, which are the nutrient-rich byproducts from wastewater treatment plants and that are often used as fertilizer on farmlands. My focus is on the soil-water interface, particularly looking at how PFAS move through soil when they enter from landfill leachate or biosolid land application to the environment. In this part of my presentation, I will briefly talk about the related research I've done, and I promise that it will be really brief. One of the major focuses of my research has been understanding PFAS contamination from biosolids, especially here in Maine. As shown in the graph, biosolids were heavily applied to farmland across the state, especially between 1989 and 1998. At the time, they were seen as a sustainable soil amendment, but no one realized they also carried PFAS. Here, this map shows some of the areas with the highest PFAS contamination in Maine. In 2016, PFAS contamination was first discovered in farm fields. By 2019, over 90% of tested wastewater sludge across the state showed PFAS presence. And finally, in 2022, Maine became the first state to ban land application of sludge due to PFAS persistence. And that same year, our research team received the Mitchell Center Award from University of Maine for outstanding contribution toward the development of a solution. In 2023, we published our findings in a paper that you can see here, Management of PFAS Laden Wastewater Sludge in Maine, Perspective on a Wicked Problem. And next part of my research focuses on understanding how PFAS move within landfills, especially how they can escape through damaged liner system, looking at the diagram of landfill at different layers. When waste material containing PFAS at the top of the layers break down, these chemicals enter the leachate, which then comes into contact with the geomembrane barriers. And these liners are meant to prevent leachate from reaching the environment, but even a tiny puncture can allow PFAS to pass through them. So to test this, I collected some geomembrane samples from Juniper Ridge landfill in Maine, and then I designed a lab scale system to simulate how PFAS might migrate through damaged liner. The result of this research showed that PFAS can significantly increase leachate permeation rate, specifically in damaged liners. And also this work was published in 2024 as shown in the attached picture, and you can refer to this paper for more detail about the research. And the research's title is Permeation of PFAS laden leachate in landfills as an outcome of puncture failures of high-density polyethylene geomembranes. After investigating how PFAS can escape from landfills, my next focus was on what happens once these chemicals enter the environment, specifically how they behave in the soil-water interface. To better understand this, I conducted a comprehensive review, compiling data from 18 studies to create a data set of over 1,800 KD values for 42 PFAS across about 100 soil types. We focused on three main factors affecting PFAS absorption, which are soil properties like texture, clay content, and organic carbon, PFAS characteristics such as chain length and functional group, and water chemistry, including pH and ion presence. This work helps us better understand the combined effect of soil, contaminants, and environmental factors, and supports more accurate modeling of PFAS fate in real-world soil water systems. Also, this critical review is currently being finalized and will soon be submitted for publication. My next focus in this research was launching an experimental campaign. This part of the project was guided by two main questions. First, how do PFAS reach equilibrium in different soil layers? And second, where do different PFAS end up in the soil profile? To answer this, I used data from over 300 identified sites in Maine where PFAS-laden biosolids had been applied, along with more than 1,500 soil composition data points. From this, I built a representative soil profile. And by using that model, I prepared 4 soil layer mixture in the lab and exposed them to different PFAS types for performing kinetic adsorption experiments. And our preliminary results were presented in NEBRA poster contest, and I was able to receive the second place of Best Poster Award from NEBRA, the Northeast Biosolids and Residuals Association, in that year. And once the full experimental data set is complete, we plan to submit this work for publication in 2025. Now that I have walked you through my research journey, I'd like to close by sharing what's next and where I'm heading after this chapter. Looking ahead, I'm planning to graduate in 2025 and take the next step in my career, bringing what I've learned into the real world environmental challenges. And right now, I'm interested in joining the environmental consulting or technology industry where I can apply my skills to support data-driven solution in water systems, contamination, design, and sustainability. And my goal is to bring value to my future team through problem solving, cross disciplinary collaboration, and insightful analysis. And I also want to stay committed to continued growth through partnership, publication, and conferences. And speaking of conferences, I'm also so excited to share that I will be joining EREF team at Waste Expo in Vegas this May. So yeah, I think my next chapter is about bridging science and practice, and I'm excited to contribute to solutions that help protect our environment and communities. That brings me to the end of my presentation. Thank you all so much for being here today. I'm incredibly grateful for the support I've received from my advisor, family, friends, and of course, EREF, who have helped me shape my journey and made this research possible. And if you'd like to connect or follow up, please feel free to reach out. And finally, I'd like to introduce you someone very special. This is Dewey, the most handsome and adorable dog I know. He just turned 5 yesterday, and as you can see, he has been catching up on PFAS research as well, while borrowing my glasses, of course. And yeah, again, thank you all for being here and attending this session.
We hope everyone will join us for Dewey's Scholar Spotlight, perhaps in 2026. We'll be happy to take his application for PFAS research. Right. That was awesome. Thank you. Happy to learn more about that. We're doing a lot of research on PFAS right now. I think this is a great time to plug our PFAS resources. Just want to throw that out there. If people we actually got a couple of questions before the webinar started. One of them was about PFAS in landfill gas. And Sonia said that she is not researching that specifically. However, we at EREF just finished a complete revamp and review of our PFAS resources. So if you go to erefdn.org/PFAS, you can find over 1,500 resources, scholarly reviewed articles by EREF staff on lots of different topics related to PFAS, and there may be some landfill gas stuff in there. Okay, so Sonia, when you're not presenting to people who know about PFAS and know about science, what do you tell them? What's like the quick high school level pitch on what you're doing and why it matters?
So for example, if I want to talk about my research to one of my friends that they don't know about anything about my research, I would probably say, do you know those forever chemicals people talk about? I work with those and I study how they travel through soil and how we might stop them before they reach the water we drink. And probably I would add, it's harder than it sounds, but that's what makes it interesting to me. And a big part of my work is testing real soil and real water conditions, so the results actually reflects what happens in the environment. And because we in our daily life we are using like water, food, I think it is very understandable for them to like realize the importance of work immediately.
Okay, so curious, in your research, have you done any in looking into the actual harm levels of PFAS once they're into the human body, or is that completely separate from what you're doing?
Yeah, so that's a really good question, but it is not my expertise. There are some other researchers that are working on the health issues that PFAS can bring to people. But as far as I know, they can be some liver damage, like they can prone some cancers, but I don't know the exact like effects that they have in human body and how they work in there. I know that it wants to like attach to the like the tissues that we have in our bodies, and it won't it will build up in our body, and we cannot get rid of it easily. But about the level of being harmful, I'm not 100% sure. There are some regulations for drinking water that we should follow them. But in human body, I think the less is better always.
All right, we have a question from Nalika. She's doing river research, and she was curious, or he, I'm sorry, I do not know. They are curious, can river sediments in Maine be contaminated with PFAS?
As far as we know, PFAS is everywhere, and of course, sediments in rivers, they also can have PFAS because once they are in the environment, once they enter the environment, they can bind with soil particles, and sediments are like one of those particles that they can carry PFAS as well. So yeah, I would say that there are PFAS in sediments as well, and there are some publications focusing on that part as well and how to remove PFAS from sediments in rivers.
If you have any follow-up questions, Nalika, on that, feel free to enter those into the Q&A. Me Lee has asked, what is the, and this is one of the questions that was on my list, what's the most surprising result from your studies? Like what's something that you found that you just totally blew you away?
In my research,
Yes.
so every time that I work with PFAS and I study more about them, I really kind of get mad because they're really persistent. And the more I know about them, it's like it's a really challenging work to like just remove them or destroy them. And it makes me really surprised that why even we have this many PFAS around, like more than 4,000 type of PFAS, and we just work on maybe a few of them to compare with 4,000. And when I get to know more about PFAS and how big the family of PFAS is, I just get scared.
And you said this a second ago, that the level of health concern isn't your area of expertise. So that's something that we found in the research a lot, is that expertise on PFAS tends to be pretty myopic, and people are very focused on their specific research area. So, a question for you: if when you encounter something that isn't in your area of expertise, and you say, well, this is my opinion, but I'm not sure, like who do you go to? Who do you check with for questions that touch your area of research but
Yeah.
aren't actually in it?
Yeah. So the first resource that I will go to is reading publications related to that question. And it's pretty easy to just go to Google Scholar and just type in some keywords and find the related papers related to that question that I have. This is the first things that I go. But if I cannot find the specific answer that I'm looking for, I will ask people. I will look for peoples in this area, and I will contact them and like ask my questions, or always I will reach out to my advisor to also know his idea or if he knows someone. So I will find a way to get my answers somehow. And I think now, because we all kind of have access to internet, it's pretty easy to just go and Google our question and see how related it is to our field. And there are lots of publication in those areas as well.
Okay, so follow-up question from Nalika: are there any numerical models available right now to model PFAS transportation in water and rivers, or at least as a tracer, or is that still an open research area?
So that's a good question. I know that there are some PFAS studies that are integrated with machine learning, but I don't know exactly about if they are like in the same and specific area, or like just about how PFAS behave in water stream, and they just try to model it with different tools. But I think there should be some research out there, but I don't think that it's like as like as big as other areas about focusing on PFAS, like PFAS removal or PFAS, how to destroy PFAS. I think that's a really good area to focus on from like in future for future works. But because PFAS is a really kind of unknown chemical with unknown behavior and too many PFAS, it's sometimes hard to model them as well.
Okay. So another question from Nalika. Thank you for the great questions. What, and you can't answer this entirely, but what do you think we can do individually to reduce our the contamination of PFAS? What can I do to try to not contaminate?
That's really a great question that I was waiting for that to be asked. Because I think our share to reduce PFAS in the environment is being considered about the products that we use, because the source of PFAS in our environment is actually from our daily products. It's a man-made chemical, and it was used to produce some customer products that are useful in our daily life, like water resistance, clothes, and everything else. So if we are careful about what we use or what we buy as customers, so the amount of PFAS that we will release in the environment will be reduced as well.
Have you talked to anybody who's looking into PFAS alternatives and how we can get the same protections on our clothing and our cookware and stuff without harmful chemicals? Do you know anybody who's doing research in that space?
I don't know if someone specifically is working on alternatives, like in person, but I know that there are some other researchers or publication that they are working on alternatives, and I can see even in some advertisements for different products that they say PFAS free. So I think it's a very ongoing research and things that like companies are looking into, and they try to use less PFAS in their products as well.
I've seen an increase in cookware labeled PFAS free, shopping just random places. Charles asks, I don't think I know the answer to this from an EREF standpoint. He's interested in how PFAS affects mental health. Do you know of any group or researchers looking into the correlation between mental health and PFAS?
I don't know about that. No. The things that I know about PFAS and human health is that it's gonna take time usually for PFAS because it will build up in our body, and after some time it will show its like impact on our body, but specifically on mental health, I'm not sure about that. And
I'm
research
not
about
either.
human health issues with PFAS is still going. So they are
Yes,
still also
yes.
figuring out what's going on with PFAS and human health.
I do know that we're funding research into the correlation between PFAS and physical health. I don't know that we're doing any on mental health. Charles, if you are doing research on that, you're welcome to apply for a scholarship on that topic. It certainly would be in the realm of things we would consider funding. So yeah, if that's something that you're looking at, great. Okay, so keep the questions coming in if you have PFAS and research related questions, but a little step away from that, going back to a little more personal stuff. So Maine is a long way from Iran. So
Yes.
how did you talked a little bit about how you got here and it was during COVID and you had to wait a little bit. What got you specifically to University of Maine? You said you reached out to the advisor and did a presentation. How did you find them?
Yeah. So I was always dreamed about going abroad, and especially moving to US because of all those opportunities that it can bring. And I knew that I want to get PhD in environmental engineering. So the things that I did was looking into different environmental engineering positions available in US. And I was going through their website and their like advisors, the professor's website to read their research interest. And if it was something that would interest me, I would contact them and I would ask for a meeting to like talk about the position and see if we want to work together. And the same thing happened with my advisor. I saw the advertisement on a website, And then I looked into his website and in research interests that he had, his publication, and I found it pretty interesting and also like completely what I wanted to work on. So I reached out to him and we talked about different projects. And when I came here, I ended up working on like how PFAS interacts with soil water systems. But it was all about PFAS, but with different media. But at the end, we decided to work on PFAS in landfills, in like soil water interfaces. That was my past, but PFAS was pretty new things for me, and it was kind of like very exciting to work with something completely new. I didn't have a solid idea about what is this new emerging contaminant, and working on this was pretty exciting for me. And at the same time, I knew that it will be challenging, but it is what makes the work going, like to learn everything, to learn, to constantly learn new things.
Awesome. Um, okay, so back to the specific research, Abby asked, and I can answer a little bit of this. They said, I thought production and use of PFAS are no longer allowed in the US. 3M and others do not produce them anymore. It's mostly from old stuff and also maybe from imports that go through the control system. Thoughts on that? Not entirely true. The US has enacted bans and restrictions on some forever chemicals in food products or food cookware, food contact applications, but it is not banned entirely. Several states have different levels of bans, but also they're not all necessarily comprehensive PFAS bans. They ban specific chemicals within the family of PFAS. However, banning two chemicals among 4,000 does not mean that you're banning PFAS. So there are a bunch of different state moves and a couple of federal moves toward banning PFAS, but it's not accurate to say that there is PFAS is no longer allowed in the United States. It's still allowed to be put into different products. Sonia, feel free to add to that.
Yeah, the only things that I feel like I want to add is that PFAS is a big family, and even if they try to find alternatives, sometimes the other PFAS can change into the formers of their chemical. Like, for example, if there's precursors, they can again change to the PFAS that we know. And most of the PFAS that has been banned already is like a few PFAS like PFOA, PFOS, and it's not about all the PFAS. And as I said, they can just change themselves to the unknown PFAS even. So I don't think that it is possible to completely ban them and completely remove them unless we focus on not using them in the first place.
And a lot of bans and legislation are focused on drinking water. From my understanding, a lot of the research we've done is trying to get it out of our drinking water. And not as much attention has necessarily been placed from a policy standpoint on banning it from being produced and put into the stream at first. But you also are researching what happens once you receive the PFAS and it gets to the soil. Yeah, it's complicated. Okay, so going forward, you said you wanted to do environmental or tech consulting. Do you have any do you have companies or areas you want to work with this research?
Um, As far as I know, because the PFAS is really a hot topic, so there are companies that working on this, and I think there is a big request in industry right now to how to tackle the PFAS. And my knowledge about PFAS, I think, is just like a plus uh, to other stuff that I know in environmental engineering. But right now, because PFAS is really challenging, I can use that knowledge or skills in different industry to like help them and to like improve their systems, or if they want to come up with any remediation technologies or removing PFAS. I think I can use that knowledge in that area, but I'm interested in like environmental consulting roles, which includes like different topics. It's not just about PFAS.
Yeah, yeah, that's fair. I don't know if you'd want to spend your entire life just completely dedicated to
Yeah.
PFAS remediation, although we'd appreciate it, I'm sure. Abi has follow-up. Yes, this is accurate. Most PFAS is introduced into wastewater treatment plants through landfill leachate. That is definitely a possibility. Municipalities should not accept leachates. That is what we are lobbying for. The leachates could be treated on site and the concentrate sent back to landfills where it belongs. Any idea where most contamination come from, if not from landfills? If you're talking about soil contamination, Abi, I'll let Sonia speak to that. But if you're talking about human contamination, obviously it comes from direct contact with products that contain PFAS. And once the PFAS is in our bodies from the various products that we're contacting or eating, obviously it can be excreted and then it's in the sewage and the wastewater. So PFAS is coming through sewer and wastewater, which is another way that does not involve the landfill.
Yeah.
I do know that landfills are one of the I don't remember the verbiage, the suggested treatment or I don't remember the word, but in the EPA's interim guidance, landfills are a suggested disposal method. I Yeah, I'm sure Abi would like to talk to you. They are also Iranian, and they are working on PFAS removal through membrane technologies, Iranian American, and would entertain talking. So we might be able to let y'all talk later. But Sonia, do you have any question or any follow up about the wastewater treatment and landfill leachate?
No, just to answer that previous question, to just add to that, as I mentioned in my slides in my presentation, and there are 4 different carriers for PFAS, and wastewater treatment or landfill leachate is one of them. Biosolids and firefighting foams are the other ones that they can also carry PFAS, but we should also keep that in mind that uh, landfills are necessary to have. They are actually good things. They are protecting us from like contaminants, but because of the nature of PFAS, it's a little bit tricky to work with that. And I think that we should just make our landfills more smarter. And I think the future of like waste management will be like more science-based, and we can use all this science to improve things, because all of them at the end of the day are useful for humans.
Agree. We'll have high tech landfills. That was one of the things that I was surprised at learning in the waste industry space is how landfill owners and general waste industry people are much more on the cutting edge of technology than people who are just simply throwing things in a trash can that gets picked up on Thursdays are aware of. How would you say PFAS is compared to asbestos? Charles asked that question.
If it is kind of adsorbent, which I think it is, I haven't worked with that. But we should look into like what kind of adsorbent it is, what kind of functional group it has, so how it can bind with PFAS.
This is actually a comparison that we have made here at EREF and some of our communications is that there is sort of a societal comparison between PFAS and asbestos. They both were introduced as something that was really going to make life better and products better and be really good. And then over time, we realized they were actually poisoning us and bad things. So there is sort of a comparison there, at least into their incorporation into products and then eventually having to be removed. All right. So in our last little bit, there are 3 questions here that I did want to get to. So what's something that no one would assume about you? They'd be surprised to find out about Sonia. Not necessarily PFAS related.
Yeah, um, that's a good question. So I would say that people will be surprised when they see that how I am like interested in going out of my comfort zone. For example, um, I like to push myself out of my comfort zone, as I said. As a memory that I had for this, I never liked dancing before, like ever. But 2 years ago, I saw the annual dance festival at my university, and something just clicked. I talked to some of my friends, and we did a Persian dance performance on a stage. And even my mom was shocked. She told me she never imagined I would do something like that. So yeah, I think that I'm really ready to take risks and like go out of my comfort zone because I feel like life happens at the edge.
Did your family get to watch that remotely?
Yeah, with YouTube,
That's
yeah,
fun.
it's still there.
Have have they been able to come visit you here?
No, unfortunately not. No.
All right. So if you weren't doing this research, if you hadn't ended up with PFAS, where else might you have ended up? Do you think you'd still be doing science, just a different
Yeah,
area of research, or something else
yeah.
completely?
I
Or
think,
leading a Persian dance troupe, potentially.
and I don't think that I will continue that professionally, but as fun things to do, yes, I think. But I think even in other majors, I would still be getting my PhD in that area as well. I just really enjoy constantly learning, as I said. But I probably choose something that mixes creativity with problem solving because I think I'm good at coming up with new ideas and methods. I also enjoy organizing things and bringing people together. So I think because I had some leadership roles in the schools, and those experiences were really meaningful to me. I think I would also think about those as well.
Um, Ooh, interesting. I'll bet you we can't answer this one. Although I like the question. Most of the adverse effects of drugs are often known prior to their release, but are hidden by manufacturers. EREF does not support or condone this statement, but I'm reading it aloud. Did you find any adverse effects of some PFAS that might have been known prior and maybe researchers hid them? I'm going to advise you not to answer this question, but you feel free and go ahead and share what you
Um,
know.
Actually, I don't know about that. The things that I knew about PFAS is it meant to be something to serve us. And
Hmm.
after some years, we realized that it has some like adverse effect on our health and environment. So that's why we are working on how to deal with it right now. But before, it was like a new technology to help
Yeah.
people.
Well, and Charles, to your point, I mean, we know the adverse effects now. They're well publicized. We may not necessarily know the severity of the negative effects of PFAS, but we know that there are uh, a negative correlation to human ingestion contacts with PFAS, and yet it's still being put in products. So I don't think anybody's hiding it at the moment. I think that the problem is right now there isn't an effective solution that gets us what we need that isn't PFAS. So hopefully that is through the work of Sonia and other EREF funded scholars. We will get there. All right, so wrapping up in a minute here, what do you think that PFAS is probably the biggest waste industry challenge right now? One of, do you think there's something bigger? What's your like the industry has to tackle something huge. Is it PFAS, or do you think there are other big challenges on the horizon of the same scale?
No, I think there are other big challenges as well. One of the challenges that I really like to work on and like and make things better in that area is just providing clean water, clean drinking water for everyone around the world. And I think that's a really big challenge, and that it really breaks my heart when I think that some people around the world doesn't have access to this basic need. So I think this is one of the biggest challenges that we face.
I would say that as someone who was born and raised in middle class America, that is not something that comes across my brain as often as it should. So thank you for bringing that up. That is definitely a global challenge. All right. So now Dewey just turned 5,
Yeah.
but you've only been in America since 2021. So did you bring him from Iran or did you adopt?
No, no, actually, Dewey is my boyfriend dog. So
Oh, okay. Oh, you didn't mention that,
yeah, I mean,
but
I just wanted to be focused on Dewey because it was his birthday. Yeah. Yeah.
well,
So
I hope the
we had
classes
him for
help
5 days. Yeah.
him understand the research. All right. Well, thank you so much for being with us. This was an excellent presentation. If you have any last minute questions, y'all feel free to type them in the chat real quickly. We want to make sure we invite, Sonia, you can put up that last slide now if you want to. Share your screen again with that last slide. We want to invite everyone to our next science session, which will be May 15th. That is also a Thursday. It is the week after Waste Expo. The EREF team, a lot of us will be headed out to Vegas next week. This will be on our findings from fires in the materials management sector report. That report is available on our website. It's actually on the homepage. You can access it. We will also be uploading the executive summary and key findings to that report soon. We have a couple of tweaks to make to those before they get published. Join us for that. This event is on our website on the events page. You can register now. Again, feel free to learn more at the link that I put in the chat, erefdn.org/PFAS. That's just sort of a informational page, but it links to our PFAS resources spreadsheet. We have a number of key resources on the website and then an entire spreadsheet, over 1,500 resources on the topic. We hope that you will attend future science sessions. If you have any questions, please email us at events@erefdn.org. And if you have further questions for Sonia or would like to get in contact with her, please email us at events and we will see if we can make that happen. All right. Thank you so much for joining us. And this will be, it is recorded and will be put on our YouTube page. Otherwise, we'll see you all next time.
Thank you. Thank you for your time and opportunity. Have a good day.
Thanks, Sonia.